Hello. Okay, so today we are still working with triangles. As I said, we'll be working with them for a while. We talked about ratios and proportions last time, and we did talk a little bit about triangles being similar. It's very similar to them being congruent. So today we're just going to focus on similar triangles. So first off, please know there are two criteria that must be met. So there has to be two criteria. So we have to have corresponding angles. So the angles that go together, the angles have to be congruent and their sides have to be proportional. So remember we set up those proportions last time. So you have to make sure that they are proportional. It says, however, if you don't know the measure of all the sides and angles, is there another way to tell? So there are several theorems that allow us, and there's really not several, there's only three, that allow us to show that triangles are similar. Okay, the first one is angle similarity. So that means if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. And think about what that means. If these two angles add up to 150 and these two add up to 150, then these two have to be congruent, so they're automatically going to be similar. So let's look at what that looks like. It says, can these triangles be proven similar by angle? If so, write a similarity statement. All right, so I know that this angle is congruent to this angle because they're both 90. I know this angle is congruent to this angle because they're vertical. So yes, I have two angles that are congruent. So I'm going to go 1, 2, 3. Angle 1 is congruent to angle D. C is congruent to B. And this one gets a 3 again. So I get A, C, E. So A, C, E, and D, B, E. And triangle D, B, E. All right, so now let's look at this one. Right off, I know this angle is congruent to this one because they're vertical. I have parallel lines because that's what these arrows mean. So if I have parallel lines and transversals, then I have more congruent angles. So I'm going to go with this one here. Is congruent to this one down here because they're alternate interior. And then this one would be congruent to this one down here because they're alternate interior. So I would say, yes, most definitely these two are similar at angle, because I have all the angles. So I'm going to say J, K, H. So angle J is congruent to F, K is congruent to G, and H is congruent to H. So can we use angle similarity to find missing measurements? So if it's given that AB is parallel to CD, so I'm going to say AB is parallel to CD. AB is 4. AE is 3x plus 1. CD is 8. And ED, which would be this side over here, is x plus 12. Now keep in mind you have to pair the sides together that go together, like this angle is congruent to this one here because of the parallel lines. This one is congruent to this one because they're vertical. So I have to pair those two sides together because they're both in between those two angles. So I'm going to pair the 4 with the 8 because they're on the ends. And I'm going to set it equal to, since I used the 4 first, then I have to use 3x plus 1 first over x plus 12. And now this looks very similar to one of the problems that we had yesterday. So I'm going to cross multiply, so I get 4 times x plus 12 equals 8 times 3x plus 1. So I get 4x plus 48 equals 24x plus 8. Okay, so if I subtract 4x from both sides, I get 48 is equal to 20x plus 8. Subtract 8 from both sides, I get that 40 is equal to 20x. Divide both sides by 20. And I find out that x is 2. So it says to find AE, so I just need to plug it back in. So AE, so since AE is 3x plus 1, that means 3 times 2 plus 1, 6 plus 1 is 7. So this side is 7. And DE, which would be this side here, this thing has a mind of its own today. DE is x plus 12. And if x is 2, that's 2 plus 12. So that would be 14. So this side would be 14. And if you notice, 4 times 2 is 8. 7 times 2 is 14. So this has a scale factor of 2. Okay, there's a second way, side angle side, just like before. It's the two sides and the angle that's included. So if in two triangles, if a pair of corresponding angles are congruent and the sides are proportional, then the triangles are similar. So can we prove these two? Well, the first thing I need to do is I need to check that the angles are actually congruent to each other. Okay, so I'm going to go over here and I see that this is 120 and this one's 120, so they are indeed. So now I need to check the scale factor. So 4 goes with 6. So 4 goes with 6, and that will reduce to 2/3. The 6 pairs with the 9 over there, so 3 goes into that 2 times. So since they have the same scale factor, then I would say yes, they are. So I'm going to say triangle MNL goes with DRQ. And then there's side, 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 which all three sides are proportional. So all you would have to do with this one is just set up the three ratios and make sure. And the way you pair them is you pick the smallest number and it pairs with the smallest number. So 3 over 9 reduces to 1/3. And then the largest number pairs with the largest number. So 5 goes with 15. So that reduces to 1/3. And then you have your two that are left over. They automatically pair together. 4 goes with 12. So that is 1/3. So since they all have the same ratio, then yes, they are similar. And I'm going to go STU. So it has to go with XWV. All right, so are these two triangles similar? Now notice, it kind of looks like there's only one triangle, but there's really not. There's really two. There's the small one here, and then there's the large one. So I'm going to redraw them. So I'm going to draw the small triangle, and then I'm going to redraw the large triangle. Notice mine aren't exactly the same, but it's okay. So I have XWV and XZY. And they tell me that this angle here, the W is 80, and that it's 80 down here. And since they both share the X, those two are automatically congruent. So by angle, angle, yes, angle, angle. So I'm going to say XWV. So triangle XWV is congruent, or I'm sorry, is similar to XZY. Same thing with this one over here. I'm going to pair them. I'm going to redraw the small triangle. Anytime they're like this, I always redraw them because it's easier. So this is LKM, LKM, and this is LJN, LJN. Seriously? I think my calibration is a little bit off. Okay, so they tell me that these two sides on the small triangle, so this is 6 and this is 10. And the big triangle goes all the way from L all the way to J. So that's the whole side, this whole side. So that's 6 plus 3, so that would be 9. So this is 9. And L and N is the whole thing, so that's 10 plus 5, so that's 15. So this one is 15. So now, since they both share the angle L, then I have possibly side, angle, side. So I just need to check. 6 over 9 reduces to 2/3. And 10 over 15, 5 goes in 2/3. All right, so yes, and they are side, angle, side. So I'm going to say LKM, LKM, and LJN, LJN. That's really ugly handwriting, and I apologize, but this thing is not cooperating today at all. All right, so here we have two triangles yet again. So we have the little one on top, and then we have the big one flipped over. So this whole piece right here, from here to here, is 12. Okay, so what I'm going to do is I'm going to set up 3 ratios because I want to see if, since I have all 3 sides labeled, I want to see if side, side, side works. So I'm going to pair the smallest number with the smallest number over here, which is 6. So I'm going to check 3 over 6. That reduces to 1/2. Then the largest number on this triangle is 6. The largest number on this triangle is 12. So 6 over 12 is 1/2. So that means the 5 and the 10 go together. So 5 goes with 10, and it reduces to 1/2. Since they all have the same ratio, they are similar by side, side, side. So now I'm going to name it. I'm going to go D, E, G. D, E, G. So DE is the side of the small one, so it pairs with HF. HF. And then it goes all the way over to E. Okay, so solve for X and solve for Y. So I'm going to solve for both. Scoot this over a little bit so I have some working room. So since this is 2 triangles, I'm going to redraw them. So I'm going to draw the larger one first. Ooh, let me start over. And I'm going to cheat. So I'm going to maybe draw the larger one. I don't think I want a right triangle though. So let's get rid of the right triangle. Can I draw a weird one? It's not going to let me do it either. Alright, so we'll just do it this way. So I'm going to draw a big triangle, and it's a lot easier for you to draw it on your paper. So there's the big one, and then here's the smaller one. Alright, so I know that these two sides are parallel, so that means this side is parallel to this side if you think about it. So that means this is a transversal, so that means that angle is congruent to that angle, which would be that one and that one. They both share angle C. So I've got 2 angles that are congruent here, so that means these are definitely going to be similar by angle, angle. So I'm just going to write angle, angle up here because that's how they're going to be similar. So the little triangle, this is 3 and this is 4. And in the big triangle, this is x and 3. So this is x plus 3. Now this big side here is the whole thing, 3 and 4. So this is going to be 7. And then this is 8. And this is y. So now all I got to do is pair them together. So the 3 goes with the x plus 3. So 3 goes with the x plus 3. And let's see, I'm going to use the 4 and the 7 because those are nice whole numbers. So the 4 goes with the 7. So now I can just cross multiply. So I get 4 times x plus 3 equals 7 times 3 is 21. 4x plus 12 equals 21. So if I subtract 12 from both sides, I get 4x equals 12, let's say 21 minus 12 is 9. And then divide both sides by 4. So, sorry. So divide both sides by 4. And I get that 4 goes into 9 2 times. 1 left over, so 225. Double check my math here. It's getting late. Alright, so now let's find, so this piece right here is 2.25. So now I'm going to do the same thing to find y. So my y pairs with the 8. So this time y pairs with the 8. And I'm going to use the 4 and the 7 again because they're nice whole sides. So when I cross multiply, I get 7y equals 8 times 4 is 32. Divide both sides by 7. So 32 divided by 7. Okay, my y goes with my 8. My 4 goes with my 7. Okay, so 32 divided by 7 is about 4.6. Just wanted to double check. All right, so now I know that this side is 3, this side is 4, and this side is 4.6. This whole side is 5.25, this whole side is 7, and this whole side is 8. So sometimes they're going to work out to just be ugly numbers. All right, are the two triangles similar? If so, what's their common ratio? So the common ratio, that means, if you remember from the last set of notes, I said they have something in common. So if you have the sides of a triangle ABC, so let's just draw this triangle here and let's just call it ABC. So A, B, and C. The sides are 4, 5, and 7. Now the measure of XYZ are a little bit bigger, so it's the same triangle, but it's bigger. So now let's call this one A goes with X, Y goes with B, and Z goes with C. And this is 16, 20, and 28. So what is their common ratio? What do they have in common? 4 times what will give me 16? 4 times what will give me 16? So X is 4. 5 times what will give me 20? 5 times 4 will give me 20. And then we have 7 times what will give me 28? 7 times 4 will give me 28. So their common ratio, or their scale factor is 4. Okay, now this one. We have PQR has sides 3, 5, and 6. STU has sides 2.5, 2, and 3. So pair them up. So 3 pairs with 2.5. So what is 3 divided by 2.5? It's 1.2. So I'm going to leave it like that, 1.2, just for a second. Then 5 divided by 2. So 5 divided by 2 is 2.5. And then I've got 6 divided by 3, which is 2. So do you see how these three have different ratios? So these two are not similar. So they have to have the same ratio to be similar. All right, so I will see you guys next class.